Hello. In this video, we're going to learn how to simplify square roots, also known as radicals. We're just going to do square roots, not cube roots or any other higher radical. And also in this video, we're only going to cover the square roots of whole numbers. We can do videos with variables in another video. So in this one, the technique is very straightforward. What we're going to do is we're going to factor what's underneath the radical. So when you factor what's under the radical, you're going to get a mix of factors, 2 times 3, 5 times 7. And what we're going to do is we're going to look for perfect squares. And if you see a perfect square, essentially what we're doing is we're taking the square root of a perfect square. So if there's a perfect square under the radical, we're going to take the square root of it and take it out. So if you saw 4 under the radical, we would take out a 2. If you saw 36 under the radical, we would take out a 6. Or you could look for pairs. Again, when we factor, we might not see a perfect square, but we might see a pair of numbers, like 2 times 2 times 3. You see a pair of numbers, what you do is you cross one out and then you bring one out. When we say bring one out, we write it in front of the radical. And lastly, you want to keep repeating these steps until you can't do 2 or 3 anymore. You want to make sure that you don't stop too early. So we're going to do a couple examples here. The first couple examples, for example, root 12, we're going to solve in 2 different ways so you can really see the various steps in this procedure. So I'm going to factor root 12, and I'm going to say that is the square root of 2 times 6. Now I don't see any perfect squares there. I don't see any pairs, so I'm going to keep going with this. And it's also important we keep writing this radical symbol. Don't just do a factor tree, because you're going to forget what's inside the radical and what's outside the radical. So if we factor 2 times 6 further, we can say 2 times 2 times 3 or 2 times 3 times 2. The order doesn't matter. And again, going back to our instructions, we're going to look for a pair. And I see a pair of 2s. What we're supposed to do, cross one out and bring one out. I like to do a little circle with a little arrow. So now 2 is in front of the radical. 2 is in front of the radical. And if you take a look, what's left behind? A 3 is left behind. So our final answer is 2 root 3. Now let's solve the same exact problem in a slightly different fashion. So the square root of 12, again, we're going to factor what's under the radical. This time I'm going to say it's 4 times 3. Now 4 times 3, you may notice, there is a perfect square. 4 is a perfect square. So the square root of 4 is 2. 2 goes in front of the radical, and what stays behind? 3. 2 root 3 is our final answer. If you notice, we should get the same answer either way we do it. Now, some of you may say, well, it was a lot easier to do it the second way. Well, that's because we recognized a perfect square. The problem is you won't always recognize perfect squares. And if you don't, then you really just have to rely on looking for pairs. So here's a good example of that, simplifying the square root of 300. So let's say I did not recognize the perfect square. And let's say I see it's an even number, so I'm just going to say 2 times 150. Now 2 times 150 can be broken down. Let's say I recognize that 150 is 15 times 10. Again, I keep writing the radical sign every single time. And I'm just still factoring. I don't see any pairs. I don't see any perfect squares. So maybe this is 2 times 3 times 5. Times, now 10 might be 2 times 5. This is all under the radical. And now this is where we look for our skill of recognizing pairs. I see a pair of 2s and I see a pair of 5s. So when you see the pair of 2s, cross out a 2 and bring out a 2. So 2 is now in front of the radical. I see a pair of 5s. Let's do this in another color. I cross out a 5 and I bring out a 5. So there's a 5 in front of the radical. And then lastly, I have the rest of the radical, which is, you just take a look. 2 got crossed out, 3 is still there, 5 got crossed out, 2 is brought out, and 5 was brought out. All I have is a 3. So my final answer, I have 2 times 5 on the outside, which is 10. 10 root 3. Now if I weren't talking so much, you would have gotten this answer pretty quickly. Now, a number of you may be saying, well, that was really ridiculous because I recognized there was a perfect square. And you'd be absolutely right. So the square root of 300 is the same as the square root of 3 times 100. And 100 is a great perfect square. 100, or I should say the square root of 100, is 10. So 10 comes out in front. Again, I was underlining my perfect squares. Square root of 100 is 10. 10 comes out, and 3 is left behind. My final answer is 10 root 3. You get the same answer either way. Now, the point that I'm trying to make is not that you're supposed to do it the long way or the short way. The point is that you should recognize perfect squares, and you should also recognize pairs, because both will come up in your factoring procedures. Let's take a look at a couple more problems. How about if we have a number in front of the radical? This simply means 2 times the square root of 27. So we'll follow the same rules. 2 times the square root of, now factor what's under the radical. In this case, 27 is 3 times 9. And we can recognize that 9 is a perfect square, so let's underline that. So the square root of 9 is 3, so 2 is joined by a 3. 3 came outside of the radical. Square root of 9 is 3. And our final answer is 6 root 3. How about this one on the right? What do we do with this situation? Here we have square root of 2 times the square root of 14. Well, there's a rule that says that if you have the same radical, meaning in this case square roots, you can actually multiply them. And I don't mean to say 2 times 14 is 28. Remember, don't be in a rush to multiply. We can just leave that as 2 times 14. Just put it under one radical symbol. And now we follow the same steps that we have been following, which is to factor what's under the radical. And here it's 2 times 2 times 7. And I see a pair. I see a pair of 2's. I'm going to cross out a 2 and bring out a 2. And I'm left with 2 root 7. Now there are several pitfalls that you're going to encounter. So let's just give you some caution. Let's say I'm trying to factor, or I'm trying to take the square root of 48, at least simplify the square root of 48. And let's say I know my times tables pretty well, and I say 48, I really see there's a perfect square in 48, and that's 4. So it's 4 times 12, and I recognize that that 4 is a perfect square. Square root of 4 is 2, and then the 12 stayed behind. And I might be tempted to say that's the final answer. But it's not the final answer, because I did not go far enough. Remember, with our rules, step number 4 is we're supposed to keep factoring until you can't do number 2 or number 3. Don't just factor once and then stop. We're going to keep factoring. So getting back to our problem, I really should have done more factoring. So instead of just stopping with that 4, I should have said, what's the 12? Well, there's actually another 4 underneath the 12. And my final answer is 4 root 3. That's the correct answer. How about the square root of 18? So I'm going to make a mistake here. I'm going to factor it correctly. Let's say it's 3 times 6, and I want to keep going. So let's say I see a 3 times a 3 times a 2. And what sometimes students do is they see a 3, they see a 2, they're like, well, one of them's going to come out and one of them's going to stay behind. So it's 2 root 3. But this person wasn't actually following the rules. This person was just seeing, hey, I've got two numbers of one and one number of the other, and one stays behind and one comes out in front, and they essentially flipped a coin. And this is the wrong answer. You don't flip a coin, you follow the rules. And the rules state that if you see a pair, you cross one of the pair out and you bring the other pair out. So the final answer is actually 3 root 2. That's the correct answer. Let's take a look at this one, which may become a little bit long, but we're going to plod through it. So here's 5 root 72. Now when I take a look at 72, there's going to be a lot of possibilities here, but I think the easiest one might be to do 12 times 6. And let's say I'm not necessarily going to do this the most efficient way, so this might be a 3 times 4 times 6, and I can keep going. I can see, oh, that 4 is a perfect square, but let's keep factoring, see if I can break this 6 down. 2 times 3. And then I might recognize, hey, I've got some things that I can work with here. I've got a perfect square, 4. The square root of 4 is 2, so 2 comes out in front. And I also see a pair of 3's. I cross out a 3, and I can bring out a 3. So I'm kind of doing a mix of problems, a mix of skills in this one problem. So what was left behind? Well, it looks like just that 2 is left behind. This 1, 2 is the only thing I have left. So I might say the final answer is 6 root 2. And that answer is wrong. 6 root 2 is wrong. And the reason why it's wrong is because I forgot that I was supposed to have a 5 out in front of the radical. This was 5 root 72, not just root 72. In other words, I got lazy. I really should have written this 5 out in front of every single line. You want to be disciplined to actually include the details of the problem. So this would have been 5 times 6 times root 2. So the correct final answer is 30 root 2. So just be careful of some of those pitfalls.